what you have to understand is that when you have two angles like this, these are called supplementary angles. And what it is they form a straight line. Okay? Your straight line is down here. These two angles, this one and this one, when you put them together, they make a straight line. But it also could be viewed as a half of a circle. Okay? And you should know that a full circle is 360 degrees. So half a circle would be half of that, which is 180 degrees. So you can say that this angle, 3p minus 5, plus this angle, which is p, equals 180 degrees. Okay, and then you solve it. 3p plus 1p is 4p. 4p minus 5 equals 180. So, there's your answer. Number 2, if you take these two pieces and you push them together, okay, they're going to fit. They're going to fit together right here. And you're going to have the same thing you had up here. You're going to have this angle plus this angle are going to form this straight line right here. So this angle plus this angle, once again, should equal 180. So 140 plus question mark, I'm just going to call it x, equals 180. So x is 40. Number 3. If angle V and angle Z are complementary, and angle V is 2 times bigger than Z, what equation will allow you to find the measure of angle Z? Okay. A couple of things here. Complementary. And while we're at it, I want to go ahead and talk about supplementary. Because a lot of times people get these mixed up. They know what they both mean, they get them mixed up. Okay. Complementary angles are two angles that add up to 90 degrees. Okay? It's two angles that add up to 90 degrees. Supplementary is the other one. It's two angles that add up to 180 degrees. Okay, now a lot of times people will remember those two numbers, but they'll get the two mixed up. And a little trick that you can use to remember which one's which, in complementary, take the first letter, that C, you can turn that C into a 9 just by doing that right there. Okay? And that's the 9. Supplementary, you can turn that S into an 8. 180 has an 8 in it. So that's a good little trick to remember that by. Up here, these two angles, since they added up to 180, those two angles are called supplementary angles. Complementary angles are going to add up to 90 degrees. Okay? They're going to look like this. Okay, you got a right angle like that. And you know a right angle is 90 degrees. So if these are your two angles together, they form a right angle. Then those two angles are complementary. Okay, now let's look at our problem. V and Z are complementary, so we know V plus Z, and I'm just going to use the letters. V plus Z equals 90. Okay, this symbol here in front of the V and Z just means angle. Okay, I'm just going to go ahead and use the letters, just keep it simple. Angle V is 2 times bigger than Z. Okay, this right here is the key. Okay, when we write angle V is 2 times bigger than Z, we need to say V is, because equals means is, V is 2 times bigger than Z. It's 2 times Z. Okay? Now, this is where it's a little bit tricky. What you have to understand here is that when you have these two things equal to each other like this, you can substitute one for the other. Okay? If two things are equal, that means they're substitutes for one another. So I can substitute 2Z in for V. And I want to do that up here. Where this V is, up here, instead of writing V, I want to write its substitute, which is 2Z. So I'm just changing that to 2Z because they're substitutes for each other. And then I'm going to rewrite the rest of this. Plus Z equals 90. There's my answer. Okay, number 4. D and A are supplementary. So D plus A equals, since they're supplementary, they equal 180. They're telling us that the measure of angle D is N. So I'm going to change that to N. And you're telling us that the measure of angle A is P. So I'm going to change A to P. Just like that. And then we're just supposed to find P. So P would equal, we'll subtract N from both sides. P equals 180 minus N. Okay. Once again, what kind of angles are those? Well, that tells us right there that they add up to 90, so they're complementary angles. You don't even have to know that here, you just have to know they add up to 90. So I can say this angle plus this angle equals 90. So 3C plus C equals 90. There it is. Number 2. S and T are supplementary. So S plus T equals 180. T is 30 less than S. T is 30 less than S. You have to put S minus 30. Okay? Now, these are substitutes for one another. I can substitute S minus 30 in for T. And I'm going to do that up here at this T. So I'm going to rewrite this S plus T, but instead of T, I'm going to write S minus 30 equals 180. Okay. S plus S minus 30 equals 180. Number 3. What pairs of angles are supplementary? Okay, which ones add up to 180? Okay, now you know 1 and 2 adds up to 180, or 1 and 3, 3 and 4, those all add up to 180. Those are supplementary. They don't have any of those in the answer choices. So you got to do a little more work here. Angle 2 and 6, let's look at those two. Okay. Now, angles 2 and 6 are called corresponding angles because they're in the same position. They're on these two parallel lines right here. Angles 2 is at the top right corner, and so is angle 6. It's at the top right corner of these 4 angles. So those are called corresponding angles. That means those angles are congruent. Okay. Now congruent means they have the same measure. That doesn't mean the same thing as being supplementary. So that one's not correct. Angle 3 and 6. Okay. Now these two angles are both on the interior of the parallel lines. Okay. Here's your parallel lines. These are both on the interior, okay, as opposed to out here, which is the exterior. Okay. And we call these alternate interior angles because they're both on the interior, but they're on opposite sides of the transversal. This is the transversal. Okay. So 3 and 6 are called alternate interior, as are 4 and 5. Those are alternate interior. And the thing about alternate interior angles, just like with our corresponding angles that we talked about before, alternate interior angles are also congruent. So 3 and 6 are congruent. So that's not the answer. C, 7 and 6. Look at those two. Here's another type of angle pairs that we're going to talk about. And before we go on, one thing you need to understand here is that these are parallel lines. Even though it didn't tell us in the problem, a lot of times it will tell you that the lines are parallel. We can assume that those are parallel lines. 7 and 6 are called vertical angles. And vertical angles are congruent. So once again, those are not supplementary. So 7 and 6 would be vertical, 5 and 8 would be vertical, 3 and 2 would be vertical, 1 and 4 would be vertical. Okay, so hopefully this is the answer. Angles 1 and 6. Angle 1, angle 6. Those should be supplementary. Now, we said before that 1 and 2 are supplementary. You know that because they form a half circle. So we know 1 and 2 are supplementary. We also know that 2 and 6 are what? They're corresponding angles. We talked about that right here. And what about corresponding angles is true? They're congruent. So if 6 is congruent to 2, and 2 is supplementary with 1, then I should be able to replace 2 with 6 And then that would make 1 and 6 supplementary. Because 6 is congruent to 2. And 2 is supplementary with 1. So I can replace 2 and 6. Substitute them. So that is the answer. Okay. Find the equation that can be used to find the total area of the composite figure. A composite figure just means it's the entire figure. Okay? It's this whole figure right here. We don't have a name for this shape because it's composed. Okay? It's composed of a rectangle and a triangle. So when you find the composite area of a figure like this, you have to break it up into its pieces and find the area of each piece and then add those together. So our rectangle, that's pretty easy. I'm just going to put a little r here this will be area of the rectangle. It's length times width. And they're calling the length L here and the width W, so we can just write it just like that. Length times width. Or length times width. Okay? And we also need to know the area of the triangle. Make those a little smaller. Those are just little subscripts. These are both area formulas, but they're different formulas because this is the area of a rectangle. This is the area of a triangle. And you get these formulas right off of your formula chart. The area of a triangle is base times height over 2. But if you notice in your answers, you don't have B and H in your answers. You only have L and W. Okay, look at all of your answers. So we need to rewrite this in terms of L and W. So let's look at our base and height for our triangle. Okay, obviously the height right here is the same as the width over here. So I can replace height with W. And the base of our triangle is right here. And anytime you have a little mark like this, it denotes that that side is congruent to these other ones. Okay? These other ones that are W, well this side is congruent to them. So the base is also W. Okay? So now we've got everything written in terms of L and W. And if you look at the answers, one thing you'll notice here is I've got a fraction here with a 2 in the denominator. The only answer I see like that is this one. So use little clues like that. That's probably going to be the answer. Now what they've done here is they've taken these two things, they've added them together. I'm going to call this area composite with a C subscript. I'm going to put the triangle area first. You'll see why in just a minute. Plus the rectangle area, LW. Okay? So there's an answer for the composite area. I mean, we could say this is the answer, but that's not in any of our answer choices, so we need to simplify it a little bit. And what they've done is they've taken this common factor of W. Okay, there's a W here, and there's there's W times W here, but there is a W here and a W here. That's called a common factor, and I can factor it out of this expression. So I'm going to factor it out like this. You know what the distributive property is, where you take this and multiply it by everything inside the parentheses. Well, factoring this factor out is just the reverse of applying the distributive property. So I'm going to factor this out. When I factor it out of this, it takes out one of these W's, and I have W over 2 plus, when I factor this W out of LW, I'm left with just L. Okay? And that's the answer right there. Okay, number 2, total area. There's a couple of different ways you can do this. You could think of it as 2 rectangles like that, or 2 rectangles like that. Either way. Okay, I'm going to do it this way and see what we get. Okay. Area, rectangle. We've actually got 2 rectangles here, so I'm going to call it area of rectangle 1, area of rectangle 2. It doesn't really matter which one's which. Okay, let's do the one on the left as rectangle 1. Alright, length, I'm going to call this the length. If you notice, this mark here tells you that this side right here is the same as this, which is x. Okay, so I've got x here, but then down here I've got another x that's equal to this. So this side, the total length of it is 2x. Okay, and since this and this are the same, this is x. Now I can plug in my formula. Rectangle 1 is going to be 2x times x. Rectangle 2, 2x times x. Same thing. And 2x times x is just 2x squared. And there's another 2x squared. And then I can just add up those 2 areas. 2x squared plus 2x squared, they're common terms, so you can add them and get 4x squared. Okay. You also could have thought of this as 4 of these. Each one of these squares is x by x. Okay? That's x, that's x, that's x, that's x. Each one of those little squares is x times x. X times x is x squared. There's 4 of those. That's 4x squared. That's how you measure area. Area is just a bunch of little squares that you count up. Okay? Number 3. Okay. Here's one that takes a little more work. All right, we've got a square and we've got a half circle here. And the square is easy enough. It's just d times d. So it's d squared. Okay, that one's easy. But the circle, and it's actually a half circle, so I'm going to call it area of half circle. Just name it that. Okay. the area of a circle, and you look on your formula chart, it's pi r squared. But since it's a half circle, we're going to put that over 2. Okay? If you notice in your answers, we don't have r in any of our answers. We only have d. Okay? So we need to change r to d. And the way we do that, r equals d over 2. Because the radius is half of the diameter. It's the diameter divided by 2. So here's what you have to use for r. So let's go over here where it says r. We're going to say d over 2. And I'm going to put that in parentheses. Okay? Now it's just a matter of multiplying this out. Okay? I'm going to come up here and do the work for this one. I've got pi d over 2 squared. That whole thing is squared. And then that's all over 2. Okay? And this is just the area of the half circle that we're working on right here. We've already done the area of the square, and it came out to d squared. Okay, let's simplify this. Pi. Now, when you square a fraction like this, you square the top and you square the bottom. So, d squared, and then 2 squared is 4. So, I just put pi with the d, I squared the d, made it d squared, and then I squared the 2, put it underneath. 2 squared is 4. And then all this is still over 2. Okay? So I've got to put it over 2. Now, if you remember from pre-algebra, when you divide fractions, and I want to think of this as a fraction, this 2 down here, I can think of it as a fraction, just like that. Let's call it 2 over 1. When you divide fractions, what you actually do is you multiply. I'm taking this fraction and I'm dividing it by this fraction. So when you do that, you actually take the first one and you multiply it by the reciprocal. So I'm going to flip the 2 and the 1 and make it 1/2. Because isn't that what you're doing when you divide by 2? You're just halving something. You're taking half of it. It's the same thing as dividing by 2. Okay? Now look what you got. Pi d squared over 4 times 2 is 8. Okay. And you can kind of see where we're going with this. We've got an 8 in the denominator. C looks like it's going to be the right answer. But what you've got now is you've got d squared plus pi d squared over 8. Okay, let's write all that out again. D squared plus pi d squared over 8. Okay, that's our answer. But we're going to factor out this d squared because there's a d squared in this term. There's also a d squared in this term. We can factor that out. D squared times 1 gives me d squared. D squared times pi over 8 gives me pi d squared over 8. And there's our answer. Now, I know that was a lot of work. If you don't quite understand that one, don't feel bad, don't panic. Okay, this is actually one of the harder problems that you'll be doing in this study. But if you need to rewind the tape, go over it again until you fully understand that would be good. Take it step by step. Okay. Number one, Lewis had edging around a square garden with sides of 11 feet. So, draw this out. Here's his garden. The sides are 11 feet. It's a square. He wants to replace the garden with a circular area for a pool. What is the largest diameter pool he can have using the old edging? Okay. So what we're doing is we're going to use this edging. We're going to reuse it. So we need to find out how much we have. Okay. So you just find the perimeter, and that's going to equal 11 times 4, which is 44. Okay. So 44 is the amount of edging that we have. We're going to replace the garden with a circular area for a pool. We're going to use the old edging. Okay, but now we're going to make it into a circle. So our circle, we're using the edging out here. What is this called on a circle? The outside of the circle is called the circumference. So circumference is going to equal 44. We need to find out what the diameter is. Okay, so C, let's use the formula for diameter. For circumference. Circumference equals 2, look at your formula chart. Pi times diameter. Okay? Pi times diameter. So now we can replace 44 for the C. 44 equals pi times diameter. Solve it for D. So you divide by pi. And 44 divided by pi is going to be approximately 14 feet. Number 2. We got a circle, circular flower bed, has a 4-foot radius. Okay, 4-foot radius. The landscaper wants to redesign the bed to be a square. What is the largest side length of the square bed the landscaper can design, so he does not have to buy new edging? Okay, it's the same type of problem. Taking the edging that's around this circle, and we're going to make it into a square. So we need to find the distance around this, because we want to know what the outside of this is, how long it is. So we need to find the circumference. Okay. Now we're going to use a formula that has the radius in it. And that is 2 pi times radius. And that's going to equal 2 times pi times 4. That's about 25, 13. Okay, so that's how much edging we have. But we want to make that into a square. Well, a square is 4 sides, and they're all the same. So we can just take that number, divide it by 4, and we'll get the length of one side. About 6 feet. Okay. Number 3. Get a circle with a diameter of 26. She used all the fencing from the circular garden. Okay. Once again, we're using the outside, so we need to find the length of the circumference to enclose a square dog run. And we're going to make a square. So it's just like number 2. Diameter is 26. Circumference equals pi times diameter. So pi times 26 is about 80, close to 82. I'm going to round it up to 82. And we're going to take that edging that's 82 feet long, divide it by 4 sides, 4 equal sides in a square, and we get about 20 for each side. The length of each side is about 20. Okay, number 4. We have a circle with a radius of 3 units. And radius is 3. And we're going to take it and change the shape to a square that has approximately the same perimeter. Okay, so same perimeter as the circumference of the circle. It's the same thing we were doing up here. The sides of the square will be, okay, so let's find the circumference. And the radius is 3. Circumference is 2 pi times radius. Notice I'm using the formula that has radius in it. Up here, I use the formula for circumference that has diameter in it, because we were dealing with diameter in this problem. Here, we're dealing with radius. Okay? 2 pi radius, so that circumference is going to be 2 times pi times 3. And that's about 19. Rounded up to 19. And I want to know the sides of the square, so we need to divide that by 4. And we get about 4.7. Okay. Okay, one thing that I want to go over with you before we start this is the idea that a triangle, when you take a triangle, and this is true of any triangle, the 3 angles, when you add them up, equals 180 degrees. Okay? And you really need to understand that. I mean, that's something you just need to memorize. A triangle, the sum of the angles equals 180 degrees. And we're going to use that idea in this lesson quite a bit, so make sure you understand that. Now, if I take a rectangle, now you know a rectangle has 4 90-degree angles in it, so you could just add those up and find that it equals 360 degrees. Okay. But if it wasn't a rectangle, and it was just some 4-sided figure like this, quadrilateral, it's not very good, but yeah. Okay, it's not a rectangle anymore, but it is a 4-sided figure. One thing you could do is divide it up into 2 triangles like that, And since we know a triangle is 180 degrees, then two of them have to be 180 times 2, which is 360. Okay. If you have a five-sided figure, like that, I'm going to pick one point here, right here, and I'm going to draw triangles out from there. There and there. How many triangles do I have? There's 3 triangles, so I could say 3 times 180 equals 540, and so on. Okay. Every time you add another side, you're going to be able to draw another triangle in there, which is going to add another 180 degrees to the total sum of the angles. Okay, so let's use this information and apply it to this problem. Number 1, in the figure below, line segment JA here is parallel to line segment EI, and line segment NI is perpendicular to EI. So that makes a 90-degree angle. The measure of angle JAN is 110 degrees. Okay, JAN. Here's J, here's A, here's N. So JAN is this angle right here. And we're given that it's 110 degrees. Now we know these are all 90, so that's what the little symbol there means. So right angle, so it's 90. So we know those 4 angles, and they want us to find the measure of angle ANI. ANI, right here. So we just need to find this missing angle. Well, since it's a 5-sided figure, we can use this one, and from that we know that there needs to be a total of 540 degrees in these interior angles. Well, we've got all our angles except one, so what we can do is add these up, add these 4 angles up, and you get 380. And then you just subtract 380 from 540, and you get 160. So you would bubble in 160 just like that. Okay. The way we did this down here, here's my 5-sided figure. I'm going to draw my triangles there and there. 1, 2, 3 triangles. 3 times 180 for each triangle equals 540. Okay, number 2. Once again, we have a 5-sided figure. So again, it's going to be 540. If you want to draw the triangles, you can. Got 3 triangles. 3 times 180 is 540. So all these angles need to add up to 540. We know these 3 are 90. 90 times 3 is 270. Okay? And we don't know these 2. Now they're asking us for EPA, which is this angle right here, EPA. But we don't know it, and we also don't know this one, ENT. But we do know that these 2 are congruent. Their measures are equal. So if we take the 270 away from the 540, it leaves us with 270, which is what we've got left here. These 2 angles have to add up to that remaining amount of 270. And since they're equal, these 2 angles are congruent, then I can just divide 270 by 2, 135. So I'll bubble in 135. Each of these angles is 135. And then all 5 angles would then add up to 540. Okay? I'm going to erase this. Okay. FR is parallel to EM and perpendicular to FE. The measure of FRA is 130. So I can fill that in. And EMA is 125. Okay.
I gotta go.
Okay.
You wanna,
So we know four angles here. We just need to find RAM, which is this angle here. And that's the angle that's missing. So 90, 90, 125, 130. Add those up, and you're going to get 435. Subtract that from, it's a 5-sided figure, so we've got to add up to 540, and then you get 105. Okay. Number 2. All right, there's something a little different. Notice how they spelled out hexagon right here. This is a hexagon. It's 6 sides. It's a 6-sided figure. If you want to go ahead and draw your triangles out, there and there. How many triangles are there? There's 4. 4 times 180 is 720. So these angles need to add up to 720. And whenever you have something like this where all the sides are congruent, then all the angles are also going to be congruent. This is called a regular hexagon. It's called a regular, any shape that's all the sides are congruent, it's called regular. This is a regular hexagon. So all the angles are going to be congruent, so we can just take the 720 and divide it by the number of angles, which is 6. And that equals 120. Angle HEX. That's one of these angles here, right there, but they're all the same. They're all going to be 120. So 120, just like that. Okay. In the figure below, 1, 4, 5, and 8. 1, 4, 5, and 8. These 4 right here are congruent to each other. And 2, 3, 6, and 7. 2, 3, 6, and 7. Those are congruent. And the measure of angle 1 is 120. Okay, so here's angle 1. It's going to be 120. But if it's 120, I can't write that small. 120. If it's 120, then we know 4, 5, and 8 are also 120. Okay? Like that. What they want to know is what is the measure of angle 2. Okay. I'm going to go ahead and erase this. We need to find angle 2. And we know 2, 3, 6, and 7 are all congruent. They tell us right here. What we need to know is how many degrees are in this entire figure. So we can draw our triangles. I'm gonna start here at angle 1. I'm gonna go up here, here, go to every vertex. There, and there. So I've got 1, 2, 3, 4, 5, 6 triangles. So you do 6 times 180, 180 for each triangle, remember? And that gives me 1080. So I have 1,080 degrees total in this figure. Well, we were told that this is 120, which makes these others 120 here, all 4 of these. So I could say 4 times 120 equals 480. Subtract that from 1080. Leaves me with 600. Okay, so there's 600 degrees left, which has to be split up between 2, 3, 6, and 7. And since we know 2, 3, 6, and 7 are congruent, then I can just divide by 4. 600 divided by 4 equals 150. Each one of those angles, 2, 3, 6, and 7, is going to be 150 degrees. Okay. So angle 2 is 150 degrees. Number 2. Got a 4-sided figure, which is like a rectangle. You know rectangles are 360 degrees. If you want to draw your triangles out, it would look like that. You form 2 triangles. 2 times 180 is 360. So 360 degrees. And we know these are 90. So 90 times 2 is 180. Subtract that from 360. That leaves me with 180 degrees to be split up between these 2 angles. And what I can do here is just write an equation based on what they're naming these. One of them is 2x, one is x. That just means that this one is 2 times this one. So I can say 2x plus x adds up to 180. So equals 180. And then I can just solve that for x. 2x plus 1x is 3x. So x equals 60. Okay, now you got to be careful though. Is that the answer? Let's go back and read the question. What is the measure of SID? Here's SID. So we're talking about this angle. Okay, we're not talking about x, we're talking about 2x. So if x is 60, then 2x is 2 times 60, which is 120. Okay. And we talked a little bit about this before. When I've got angles like this is something you really need to memorize. When you see a figure like this, where you have, these are called vertical angles, okay? These are congruent, okay? Since this is 50, and this is 50. Angles would also be vertical. They would be the same. This one would be 130, this one would be 130. Okay, remember 50 plus 130 equals 180. So that would be 130, that would be 130. We don't need to know that here, but just a reminder. Okay, so since that's 50, we know this is 90, so this has to be, triangle has to add up to 180, so this has to be 40. Okay, so your answer is A. Number 2. Okay. they're telling us that this right here is 38 degrees, which means this is 38. Okay? And what they want to know here, this courtyard is formed by the intersection of these four streets. And they've kind of colored it in here. I'm going to go ahead and color it in a little more. I'm talking about this triangle right here. That's the courtyard. Okay. So right here. They want to know the measures of the angles of the courtyard. Show me 3 angles. Well, this one's 38. If this is 38, then this, since that's 90, then these two have to be 90, okay? Because all together those have to be equal 180. So this, since this is a right angle here, this has to be a right angle. So these two have to add up to 90. They're complementary. So 38 plus 52 equals 90. So that angle is 52. That's one of the angles in our courtyard. This one is obviously 90. So 52, 90, and then this one has to be 38. So that the angles of the triangle add up to 180. So 52, 38, 90.